part of our proposal. The first one is methodology, and the second one is conclude. In methodology, I will make you understand CPG, attributing, and why they need to combine with BO to improve the gain and the speed of software to that robot. So let us start with CPG. What is CPG? First, CPG stands for Central Pattern Generator. That is a neural network capable of generating rhythmic oscillatory signals and without requiring constant input. In biology, CPG are responsible for controlling rhythmic behaviors such as walking or running in animals. So this is still a bit hard to understand, right? So let me give you an example in our body, because our body is a great CPG system. So in our body, CPG is a neural network, of course, and it comes from the spinal cord. Spinal cord is part in our body, and it can automatically generate rhythmic pattern movements, such as walking or running. So imagine when you, and the important thing is that it doesn't require the brain to control every details. So imagine when you walk, like you walk forward, your brain just send a high level command that move forward, and the spinal cord coordinates the motion autonomously. Like your left leg steps, right leg steps, and repeat. This is like a loop. So this mechanism reduces the cognitive load on the brain, enable fast reflexes, such as when you step on a hot or sharp object, your foot automatically and immediately lift. So it functions like a hierarchical control system where the spinal cord handles simple reflexes and the brain focuses on higher level goals. So let's move to astronomy. As you know, we are living in a world full of smart devices, such as phones, cars, cameras, sensors, all generating huge amounts of data. Traditionally, all of this data is sent to the cloud for processing, but this method is becoming too slow and inefficient in many situations. So that brings us to astronomy. Let's take a look closer at what it is and why it is so important. So attributing means processing data closer to where the source of the data is generated, instead of sending it far away to a cloud server. So let me give you an example. Imagine a self-driving car. It collects data from sensors around the car in real time and has to make decisions very quickly. So if it had to wait for the cloud to respond, then it would be too slow. Instead, with attributing, the car can process the data right there instantly at the edge of the network. So that is how attributing works, bringing computation closer to where the source of data is generated. So the question is, why do we need to combine these three technologies? Such as it include attributing, CPG, and VO. First, the robot uses a central pattern generator based on Hopf oscillator to create rhythmic movements. A Hopf oscillator is a type of mathematical model used to generate smooth and rhythmic signals, just like those found in the biological system, such as the nervous system that control walking in animals. To be back for the CPG, so the CPG mimics the biological system, allowing the robot to produce different style gains, such as running or walking. So, but for the gain to be effective, we need to change the parameters of CPG. So that brings us to bio. So second, we need to change the amplitude, frequency, or phase offset between legs. Instead of manually adjusting the parameters, we use Bio to search for the optimal value that maximize working speed automatically. The problem is treated like a black box problem. Bio tries a set of parameters, observe the result, and uses that to guide the next trial. And now the model seems like a perfect model, but there's a big problem that what works in simulation often doesn't work on the real robot due to the reality gap. Reality gap is the difference between simulation and real world performance. So we applied multi-fidelity optimization or MF Bio. MFBO uses both simulation and experimental data. Yeah. So why do we need edge computing? The robot's onboard controller is too weak to handle all data in real time, so we use edge computing. The robot sends the sensor data like speed and body orientation to a nearby edge server via 5G. And the server runs the CPG updates and version optimization and send back the updated control parameters to the robot. So in summary, CPG creates the left movement patterns. Bio try to find the optimal values, and edge computing uploads the heavy computation. And so that is the strength and weakness of our method. And about the strength, applying multi-fidelity version optimization helps to reduce the reality gap between simulation and experiment. And applying edge computing model has reduced computational load on the robot's onboard controller. But there are still weaknesses of the method. The first one is relying heavy on simulation, especially the early phase. If the simulation go inaccurate, then the optimal gain may not transfer well to the real robot. And depending on stable communication between the robot and edge server, any delays and loss correction can make the performance not well. And there are the keywords in of us and the link in the time direct. Thank you for listening. And any question you want to ask?